Hi, Math 3. I'm back. Let's do Practice Benchmark Chapter 8, which is trigonometry. So you've done a little trigonometry in Math 2 when you learned special right triangles and angle of elevation and depression. Then you learned SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Now we're going to get right into the unit circle. In Chapter 8 in Math 3. So let's go ahead and get started. Determine the period of the function. The period is one cycle. So we're looking for one cycle, literally what that means for the period. And it repeats every cycle, right? So you can see from here to here is one full cycle, and then it's going to repeat again. So the period is one full cycle of whatever your graph is. So it looks like it goes from here to here. So this is about 2.5 and 7.5. So how long is that? Well, just go 7.5 minus 2.5 and you're going to get 5. So the period is 5. It does one full cycle in 5 units. All right, on to the next one. Determine whether the function is periodic, meaning it repeats every period. If it is, find the period. Well, looking at this graph really easily, I'm going to say no, it's not periodic. Look, it's kind of crazy. It's going up and then a little and then bumpy and then down, and maybe it could repeat here, but look, this is higher than this, so I'm going to go with no, this is not periodic. Easy peasy on that one. All right, let's look at the next one. Number 3, find the amplitude and the equation of the midline for this periodic function. Okay, the equation of the midline is super important for graphing. The amplitude is how high it goes above and below the midline. So let's look. We're down here at -2, and that looks like the lowest point the graph goes to -2. And then it goes all the way up here. It looks like 1 above 4, like it looks like it goes to 5. Okay, so it kind of pops off the graph. From -2 to 5. So I want to find the midline. Where's the middle? Well, just count from -2 to 5, or find the distance from -2 to 5. So you're going to go 1, 2, 3, 4, 5, 6, 7. That distance is 7. Now the midline will be halfway through this graph. So divide that by 2. And you're going to get 3.5. All right. Now 3.5 is going to be your amplitude, because remember, your amplitude goes from the midline up and the midline down. So that's your amplitude right there. Now the equation of the midline, it's always going to be a y equals 2 because it's a horizontal line. Okay. And the equation of the midline is going to be halfway. So if you look on this, if we go up here and down here, we want to go halfway. So count down 3.5. So from 5 we're going to go 1, 2, 3.5 right here. This is the equation of the midline. Remember, the amplitude is above and below the midline. So 3.5 above to here, 3.5 below to here. So here's the equation of the midline, and it's about 1.5. So it is at 1.5, not about. Y equals 1.5. That's your midline. So there's your midline, there's your amplitude. All right, so graphing the midline is super important for finding the amplitude. Normally, the regular graph, the midline is the x-axis, or y equals to 0. All right, let's look at a wave. It has a maximum of 1, and its midline at y equals to 0.5. What's its minimum? All right, think about this. I'm going to pull this up. Okay, remember the midline is the middle. All right, so if I were to just sketch something out here, I have some kind of wave, and I know it has a maximum of 1, so it's going to go up to 1, and then we'll put -1 down here so we can just have a reference point. It's some kind of wave. Its maximum is 1. It doesn't say its minimum is -1, just the max is 1. The midline is y equals to -0.5. So here's -0.5. here's -1, this is negative and a half. So there's my midline, -0.5. All right, there it is. So how far is the minimum? We know the maximum is here, so I go up a half and another whole. So I go up 1.5 to get to the max. That means I have to go down 1.5 to get to the min. So if I go down a half and then another 1. All right, so here we go. If I go down 1.5, it's down a half and 1. I'm going to get to -2. So what's the minimum? It's going to have to be -2. All right, remember the midline is the middle line. Your amplitude is above that and below that midline. So at -1/2, you need to go up to 1. That's 1.5 up. So the amplitude would be 1.5, and then you'd have to go 1.5 down. All right, next one. Okay, I want to sketch that angle in standard position. All right, when you're looking at a unit circle or whatever it is, you're going to go 0. And if I go counterclockwise in my rotation, this will be 90 degrees. This is 180, that's a half circle, 270, and then back to 360 all the way around. So if I want -100, well, if I go this way, it's positive 90 degrees. If I go this way, it's negative 90 degrees. So 270 is also negative 90, all right, in the negative direction. And then I want to go 10 degrees more, so it's going to be about right here. Maybe that was a little too far out. About right here. There is my -100. From here to here, I go 100 in the negative direction. Positive is counterclockwise, negative would be clockwise, all right? So there is my -100. Oh, I already marked it. All right, so number 5, there you go. Okay, we want to find the sine of 90. Without using a calculator, you can do it using your unit circle. Remember your coordinate axis, your x, y, right? This is your x, this is your y. Your x-axis is the cosine, and your y is the sine, right? If you think of it like that, in your coordinate points, all right? So with your xy point, you're going to have cosine, sine, all right? Cosine, sine. So if I want 90, this is 0, this is 90, 180, 270. We already went over that part. So I want 90, and I know the point is cosine, sine. So this over here in my unit circle, pretend like that's a unit, this point would be over 1 up 0, so 1, 0. This point right here on my unit circle would be over 0 up 1, 0, 1. So remember, it's cosine, sine. So at 90 degrees, the sine is here. It's 1. So what's the sine of 90? It's 1. All right, looking at the cosine of 300, where is that? So if we're here at 90, 180, 270, it's not all the way back to 360. It's right here at 300. So right here. So it's 30 degrees past here. And you'd have a 30, 60, 90 triangle. Now, instead of recreating the wheel all the time, I'm just going to pull over a unit circle here so we can just look at it. On our unit circle, we can see 300 is right here. It's a 30-degree angle. So with your 30, 60, 90 triangles, if you want to think of it like that, okay, this is your 30, that's your 60, this is your 90. Okay, so the coordinates at 300 are 1/2 and -3, square root of 3 over 2. It asked us for the cosine, I believe. Yeah, cosine, remember it goes cosine, then sine. So the cosine of 300 is going to be 1/2, right here. All right, cosine of 300 is 1/2. And then on to number 8. Find, round your answers to the near, oh, this one said round your answers to the nearest hundredth. You can also on a calculator or on a phone calculator go cosine. Make sure you're in degree mode. If you're in radian mode, it won't work. Cosine of 300 should give you 0.5. All right, find the exact values of cosine of 150 and sine of 150. So thinking about where that is, this is 90, this is 180, so 150 has to be in between here. So how much more is it than 90? Well, it's 50 plus 10 more, so it's 60 more right here. All right, this right here is going to be the 150 degrees. That's 90 and 180, so 150 has to be right there. Just go ahead and pull over the unit circle for sake of quickness. Let's clear that off, and I need a mouse. Okay, so we want cosine and sine of 150. So here we are, cosine and sine of 150. This will be my 30-degree angle, this will be my 90, and that'll be my 60-degree angle. So at 150, the cosine is negative square root of 3 over 2. The sine is 1/2. All right, and my 30. So cosine of 150, negative square root of 3 over 2, and the sine is 1/2. All right. This one asks to find the radian measure of an angle of 200 degrees. All right, to convert from degrees to radians, the conversion rate is pi over 180. All right, we know 180 degrees equals pi. Pi over 180 is the conversion rate from radians, or excuse me, degrees to radians. So I'm going to multiply 200 by pi over 180. That's like multiplying by 1. They are equivalent. So if I multiply these, this is going to be 200 pi over 180. And then the zeros cancel out, so I have 20 over 18. Now I can reduce that. Let's see, 2 goes into 20 10 times, and then pi's on top. And 2 goes into 18 9 times. So 10 pi over 9 would be the reduction of that. All right. Okay, number 10, we want the degree measure. So we're going to do the opposite conversion. If we have an angle in radians, pi over 5, and we want the degrees, instead of multiplying by pi over 180, I multiply by 180 over pi. And they're still equivalent, still multiplying by 1. So when we do this, we cross the pi's out, and we're left with 180 over 5. And let's see, 5 goes into 180 36 times, so 36 degrees. And there you have it. All right, we want to find the exact value of sine of negative pi over 2 radians. Okay, so now we're going to be in radians. Now think about your unit circle and where that would be. And then I'll pull over the unit circle. But I like you to think about it for a second. Let me see if I can draw a prettier circle. All right, there's a little unit circle. Now where's negative pi over 2? What does that mean? If this is 0, 90, 180, 270, then 360. In radians, this would be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So if I want negative pi over 2, I start here. Instead of going pi over 2, I go negative pi over 2. So negative pi over 2 is the same as 3 pi over 2. So right here is where I would be. And the sine, if you think about it, I go over 0, down 1. So it's 0, negative 1 for this point. So cosine, sine. So sine of negative pi over 2 is going to be negative 1. All right, check it on your unit circle. You can double check that and see the sine at negative pi over 2 is negative 1. All right, on to the next. Okay, find the length s to the nearest tenth in the circle below. That threw me off, nearest tenth. Okay, so we know the length, the arc length here. We did this in geometry where we did our value out of 360 and we did it in degrees, and now we're doing it in radians. And the formula, we did the degree out of 360 times the circumference of the circle. That's how we did it in geometry. Now in radians, that same formula gets converted to radians and turns out to be the arc length is theta times the radius. And that's how it ends up working out. And let's go ahead and do that. So we're going to go the arc length is, our theta is 3 pi over 4, and our radius is 8. So just do the math. 4 goes into 8 2 times, and then 2 times 3 pi is 6 pi. Now it asks for the answer to the nearest tenth. So I need to multiply out pi. I'm going to go 6 times pi on my calculator, and it's going to give me 18.84. Calculated to the nearest tenth would be 18.8. And it is centimeters, so I'm going to have centimeters. And there you have it. A particular sound wave can be graphed using this function. Find the amplitude of the function. Okay, so remember, when you have a graph, y equals a times sine, just to go over this, b of x, no shifting left or right or up or down. This a value is your amplitude, or the absolute value of it is your amplitude. Okay. And the b value tells you the number of cycles you make in 2 pi. And you can use 2 pi divided by b to get your period. Okay, so this tells you the number. So there are 7 cycles in the value of 2 pi for this one. And our amplitude here is 5. So find the amplitude. It's just 5. Okay, what's the graph of one cycle of a sine curve given these characteristics using the form y equals a times sine b of theta? And then what's the equation for the sine curve? So let's look right away. The amplitude is 2. We already know a is the amplitude. So I'm going to go, well, y equals 2 for a times the sine. And then b is the number of cycles from 0 to 2 pi. The period is 2 pi. And I know 2 pi divided by b gives me my period. Well, if the period is 2 pi divided by b is 2 pi, so that means b has to be 1, right? So what am I going to put in here for b? I'm just going to put 1. Instead of putting 1 theta, I just put theta. I don't need to write 1. Okay, so 2 sine theta, and that's it. I haven't shifted anywhere. A is greater than 0, so it hasn't reflected. So it's just 2, it's not negative 2. Now careful, if the amplitude was 2, this could have been negative 2, because the amplitude is the absolute value of A. Like here it was negative 5. The amplitude is still 5. You go still 5 on either direction from the midline. But here, because A is greater than 0, that's a positive. Now I go ahead and graph it. My period is 2 pi, my amplitude is 2. The rest of it's all normal. Now remember my 5 points. Okay. If you're looking, your 5 bench points when you're graphing, if you look on a unit circle, to get one full, you're going to go 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. So you have 1, 2, 3, 4, 5 points. 5 points to get a full curve around the circle. So I'm just going to mark it off like this. We're going to go 0. Let's go here to pi over 2. I just like to give it a little space. Then we're going to go pi. Then let's go 3 pi over 2. And then we'll go 2 pi. And this is good if you're shifting by pi over 4, because you would have a pi over 4 in between each of these. That would be good markings. Okay, so our 5 points. At 0, sine is 0. At pi over 2, if you look on your unit circle, at pi over 2, sine is 1. And we're going to go 1 and negative 1. However, our amplitude is 2. So instead of going up to 1, I'm going to go up to 2. At pi, the sine value is 0. And even if the amplitude is 2, it's still 0. At 3 pi over 2, it's negative 1. But instead of going at negative 1, I'm going to go down to negative 2. Down to negative 2. And then back to 2 pi, the sine value is back to 0. And I just graph my sine curve. Remember, your sine curve starts at 0 and ends at 0. And your cosine curve starts at 1 and ends at 1. All right, and there you have it. Okay, I just did this whole problem, but I didn't record it, so I got to do it again. Okay, so our amplitude, remember, y equals to a cosine b theta. A is our amplitude, B determines our period, the number of cycles between 0 and 2 pi. There's 2 of them. So my period is going to be pi. So let's look. Our amplitude is 4. So I'm going to go up to 4, down to 4. And then our period will be 2 pi divided by B. Now our B value is 2. So 2 pi divided by 2 is pi. So I get 1 full cycle in pi instead of 2 pi. Now I didn't shift left or right any or up or down any, so that's good. And I didn't reflect, so that's good. So instead of going up to 1 and down to -1, I'm going to go up to 1, 2, 3, let's see, 1, 2, 3, 4, and down to -4, 2, 3, -4. Okay, normally your cosine curve does one of these, right? Starts at 1 and ends at 1. So know what your normal cosine curve looks like. So instead of starting at 1, I'm going to do my 5 points. Okay, my first point's going to start at 4, right? And then since I'm going to go within pi, instead of going pi over 2, pi, 3 pi over 2, 2 pi, I'm going to go pi over 4, then pi over 2, then 3 pi over 4, and then my last point here will be pi, 4 pi over 4. So 1 pi over 4, 2 pi's over 4, 3 pi over 4, 4 pi over 4. 4 pi over 4 is just pi, and that's what that point is, and I couldn't fit it in. It's right there. Okay, so normally I start my cosine curve up at 1, but I start up at 4. Then my next point on my cosine curve is always the 0 point, and that's going to be here. Then I'm going to go down for my midpoint. Then I'm going to go back up for my next point. And I'm going to finish my last point all the way up at the top. And there is 1 cycle of the cosine curve, and it's so ugly. Try. All right, and that's what it should look like without being so ugly. Consider the graph of the function below. Now I just realized something. This happens to be very similar to the function we just did, but that's okay. Looking at this graph, we want to find the period and amplitude. So let's just check and see, is that the midline? Does it look like half up and half down? Well, from here I go down to -4, and here I go up to 4. So y equals to 0 is the midline. So the amplitude is from the midline, up 4 or down 4. So the amplitude will be 4. Okay, what's the period? Well, how long does it take to do 1 full cycle? You start here, you go down, you come back up, then you go down and come back up. It looks like from 0 to pi, so my period is pi. All right, now I want to write an equation. Y equals a, and then to me this looks like a cosine curve, but you could shift it and make it a sine curve. That would be harder. I would stick with the cosine curve. So I'm going to go A, cosine, and then B, theta. This is my amplitude. It will be 4, cosine. And then this tells me the number of cycles from 0 to 2 pi. Well, look, I do 1 cycle, 2 cycles. I do 2 cycles from 0 to 2 pi. So that value there is 2, theta. Or you can think of it like this, 2 pi over B equals your period. Okay, well I'm going to go, I need to figure out what B is for my equation. So I'll go 2 pi over B. I know my period by looking at the graph is pi. So what does B have to do? Or excuse me, have to be? It has to be 2, because if this is 2, 2 divided by 2 gives me just pi. So there's my equation. Y equals to 4 cosine 2 theta. Now the reason I laughed is because when I was making this test, I didn't realize that's what this is, 4 cosine 2 theta. So that's okay. That's getting the graph and looking back at how to get the graph. Or yeah, being given the graph first and then writing the equation second. Okay, what's the value of the expression? Do not use a calculator. That's not the expression. The expression is tangent 5 pi over 6. Remember, tangent, real quick, is sine of theta over cosine of theta. That is your tangent. I've given you a bunch of um, little formulas on sheets. Make sure you download them from Canvas so that you can study your identities. But tangent is sine over cosine. So really we're looking for the sine at 5 pi over 6 and the cosine at 5 pi over 6. Where is that on your unit circle? If you want to count pi's over 6's, it would go 1 pi over 6, 2 pi over 6, you're counting by 30s. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, 5 pi over 6. So you're counting by 30s right here. 30, 60, 90, 120, 150. So 5 pi over 6 lands here. We just look at what's the sine and what's the cosine. The sine is 1/2. The cosine is negative square root of 3 over 2. Remember, tangent is sine over cosine. So at 5 pi over 6, the sine is 1/2. The cosine is negative square root of 3 over 2, right? So the tangent is the sine over the cosine. That would be the tangent at 5 pi over 6. Would be the sine at 5 pi over 6 over the cosine. So we're going to go 1/2 divided by negative. It's negative square root of 3 over 2. Let's go back to, we're going to go 1/2 divided by negative square root of 3 over 2. And remember, keep flip change. Let me get my pen to work. Keep the first fraction, flip the second fraction, change the divide to multiply. So the 2's cancel out and you get 1 over negative square root of 3. Now remember that rule about not having radicals in the denominator, okay? Because they're annoying to divide by. So we're going to rationalize it. We're going to multiply the top and bottom by the square root of 3. Okay, that gets rid of the radical in the denominator. So when I do that, I get square root of 3 on top, and then square root of 3 times the square root of 3 is 3, and it is negative. So I get negative the square root of 3 over 3. And that's the tangent at 5 pi over 6. Okay, state the transformation of each function below from its parent function. Now transformations with sine, cosine, tangent curves, etc. is the same as it was with our quadratics. It's the same deal, okay? Inside with the x or the theta is opposite. Outside is the y, it's straightforward. So this would mean left 2, and then this would mean down 1. Okay, opposite with the x, straightforward with the y. All right, now let's go ahead and look at this. This is where it gets nitty-gritty. We're going to graph these. Y equals sine 2. So we're going to change our period. Then we're going to shift and this whole graph. So the best thing to do is, instead of having you graph this, I did make it on the test multiple choice, so I could easily see this without doing all the graphing. But let's first look at, remember, our basic sine function would be y equals to, and I'm going to write it over here, y equals to a sine b, and then x, or theta, I guess we'll do theta, theta minus h plus k. So this shifts you left, right. This one's up, down. And that's opposite, right? Opposite because of the minus. This gives you your period. 2 pi over b is your period, or the number of cycles from 0 to 2 pi, that tells you. This is your amplitude. Now when we did quadratics, that's stretched or compressed, which is exactly what the amplitude does, okay? And a negative would reflect, all right? So looking at this, I can see I'm going to have the number of cycles from 0 to 2 pi. I'm going to get 2 cycles. So my period will be 2 pi divided by 2, or pi. So I'm going to do 1 full cycle in pi. There's my period. Okay, I'm going to shift left pi over 2, and I'm going to shift up 3. So left pi over 2, up 3 in a period of pi. I do 2 cycles within 2 pi, okay, because I do a period of pi. Now let's go ahead and think the regular sine. I drew it, the regular sine curve, if you look at your 5 like benchmark points, right? Your 5 benchmark points at 0, pi over 2, pi, 3 pi over 2, and then 2 pi, okay? And then you go up 1, down 1. So your regular sine curve starts here, goes up for pi over 2, it hits 0 at pi, goes down for 3 pi over 2, and it comes back. Okay, so there's my 1, 2, well, I know you get right at pi over 2, 3, 4, 5 benchmark points. That's a regular sine curve. It's really okay. So knowing this is my regular sine curve and knowing I need to do 2 cycles, let's first look where our midline is. Midline is important. So our midline, back up to our equation so we can see it up here. Okay, so our midline is going to be equal to our shift. Because we shifted up 3, our midline is going to be y equals to 3. Normally our midline is y equals to 0, but we shift up 3, so this literally tells us our new midline. So let's look at our choices for the graphs. We want to go up 3, so I know it's not this graph, it shifted down 3. It's not this graph, which looks identical to this graph, so another no-no. So it has to be one of these. I need a midline at y equals to 3. This one has it. This one also has it. Now I know it has to go a period of pi, which means in 2 pi, if I scroll down here, I don't know if I can make this a little bit bigger. Hold on. Let me see if I can stretch this out, if it will mess it up. Yeah, it's going to mess it up. Okay, that's okay. That means in 2 pi, right here, I have to go 2 cycles. So 1 cycle, 2 cycles. So this would be my graph. This does 1 cosine cycle in 2 pi, but I'm looking at the sine cycle and I need it to do 2 sine cycles in 2 pi. So I know it has to be B. All right. It shifted up 3. It shifted. Normally I'd start at 0, but I'm compressing it because I'm doing it quicker. Okay, so I compressed it right here with this, and then I shifted left pi over 2. So instead of starting at 0, I shift it to the left. All right, and that's B. Let's look at the next one. This is a cosine graph, so let's first do a little sketch of the basic cosine graph. And this will be an ugly sketch because I'm drawing it freehand. So a basic sketch of the cosine graph at pi over 2, then pi, 3 pi over 2, and then 2 pi. In the cosine graph, it goes up to 1 and down to -1. Now the cosine of 0 is actually 1. The cosine of pi over 2 is 0. Cosine of pi is -1, 3 pi over 2 is 0, and then 2 pi is 1. There's my 5 benchmark points. So my cosine curve does one of these. That's my basic cosine curve. Now that's kind of goofy, but look at what we're going to do here. We're going to do an amplitude of 2. It's going to reflect, so we're going to flip it. This reflects it over the x-axis, reflect over x-axis, or y equals to 0. Okay, the x-axis is where y is 0. We're going to reflect, then we're going to shift left by pi over 4. Remember, it's opposite inside, and then we're going to shift up 2. Now, there's no number here, and that tells us our period, or the number of cycles in 2 pi. Since nothing's there, that number is 1, which means I just go to 2 pi, okay? And then my midline, this tells me my midline. Since my midline is normally y equals to 0, this shifts me up 2. So my midline is y equals to 2. So let's look at our graphs. Which one of these has a midline of y equals to 2? So this one does. This one shifted down, so it's not D. This one shifted down, not A. This one also looks like it might have a midline of y equals to 2. So it's between these two graphs. Now which one would it be? Well, my cosine graph, since it's flipped and shifted, it's still hard to tell. Okay. I lost my line. Looking at my midline here. I lost it. All right. There we go. Okay. If we were to flip this graph, I do some other things to it, and my midline is at 2. And I do have an amplitude. This has an amplitude of 2. This one has an amplitude of 2, so it's still hard to tell. So let's go ahead and see what happens when I reflect. If I reflect, let's do it in green. So all of my points will be opposite the x-axis. I'll still hit here. This one will be up here, down here, and then this point that's up here now is on the other side. So basically I'm going to flip the graph upside down. Okay. And then if I shift it left, pi over 4 is right here. I'm going to have more something like this. Okay. It's going to be shifted a little bit. So which one of these looks like that? It's still stretched because it's shifted up too, and it's stretched, but this graph comes down first and then goes up instead of starting up first and going down. It will be shifted and moved over, but it still starts down and then goes up. So it's going to be this graph right here instead of this graph up here, because it would look like it's this in that original red graph, but it's a reflection, right? Normally it'd start up and go down even if you shift it to the left. But this one, even shifting to the left, it does go up a little bit this way, but the left shift, it still would be the down and then up. It would be graph B. All right, guys, you can graph these on a grapher to double check your work, or go to Desmos.com when you're looking at this. Or just use your 5 benchmark points. Start with your midline, y equals to 2. Okay, your amplitude, you had to go up 2 and down 2 from that. Okay, you did have a reflect, which is tough. Left, pi over 4. So I took my sine curve and I had to shift it left, pi over 4. And then just find your 5 benchmark points from negative pi over 4 to a little bit before 2 pi, pi over 4 less than 2 pi, to get that full 2 pi curve in there. All right, good luck. Okay, let's do secant. Remember, secant, it's confusing because secant and sine seem similar, but secant is actually 1 over the cosine. So the secant of x equals 1 over the cosine of x. So secant of 225 would be 1 over cosine of 225. So where is that? Well, you can draw it out on your unit circle. Let's go ahead and look at where that is. On your unit circle, here's 225, and we're looking at the cosine, okay? Because secant is 1 over the cosine, so that's what we care about is the cosine. Remember, it goes cosine, sine. So at 225, cosine, sine. Here's my cosine, and they are the same because it's the pi over 4 spot. But negative square root of 2 over 2. So I know I'm 1 over the cosine. Now the cosine at 225 is negative square root of 2 over 2. And I'm 1 over that. So using your fractions, keep, flip, change. Keep the first, flip the second, 2 over negative square root of 2, and change to multiply. Well, 1 is the same as 1 over 1. So this is just going to be 1 times 2 is 2. Then 1 times negative square root of 2 is negative square root of 2. Now that would be your final answer, but oh alas, we don't like square roots on the bottom, so we're going to multiply top and bottom by root 2. And that gives me on top 2 square root of 2, and then on bottom root 2 times root 2 is 2. So this will be negative 2. And that's a negative, so I have a negative 2. And then, oh, one more step. 2 divides into 2 and gives me a 1. So this will be negative square root of 2, because the negative 2 divides into the positive 2 and leaves me with negative 1. So the answer here is negative square root of 2. All right, let's look at number 22. Simplify the trig expression below. Now this is just a basic one. Just know your cosecants, that's not cosine, cosecant. Now cosecant sounds like it would relate to cosine, but it actually relates to the sine. Cosecant of theta is 1 over the sine of theta. Okay, so cosecant, this would be written as 1 over the sine of theta times the sine of theta. Well, multiply across the top. This is sine theta over top, and then sine theta on bottom. Sine theta divided by sine theta is just 1. Okay, so know your cosecants and your secants, and your cotangents and your tangents. All right, on to the next one. What is the area of triangle ABC to the nearest tenth of a square meter? All right, just knowing the area of a triangle, when you don't have the base and the height, you can use angles. We have a formula to do that. It's 1/2 BC sine A, okay? When you have side, angle, side, you can find the area with this formula. Now, this particular formula, we happen to have angle A. If you had angle B here, this would be AC. If you had angle C here, this would be AB. So it depends on what angle you have. So just plug in your numbers. The area is 1/2. Side B would be opposite angle B, so 1/2 32. Side C would be opposite angle C, so that's also 32, times the sine of angle A, which is 77. Now you need a calculator to find sine of 77, so go ahead and do that on a calculator. Sine 77 times 32 times 32, then divide that by 2, and it's approximately 4, and that's not a very good 4, 489.9, and it says to the square meter, but it's actually centimeters. Okay, and that would be centimeters squared. Let's see if I can squish it in there. Centimeters squared. All right, and that's how you do that one. Just know that formula. All right. Law of sines. The formula for law of sines depends on which side you have, but it's just sine of B over B equals sine of A over A. So I'm going to go sine of 36 degrees over B equals sine of 74 degrees over 66. And solve for B. Cross multiply. Basic algebra. So I'm going to go 66 sine of 36 equals, and then multiply this, B times sine of 74. Then my last step to solve for B, divide by sine of 74. And that's a 7, not a 2. All right, divide both sides by sine of 74. And then this is just a calculator problem. B is going to be, and it's an approximation, sine of 36 times 66, and then divide that by the sine of 74. You might want to do the sine of 74 first, and then you get like 0.96126. That's a 2. And then do this on your calculator and divide by that. And you're going to get B is approximately 40.4. All right, and the last one. All right, this one tells us to use law of cosines. Okay, there's a couple different formulas for law of cosines. It depends on what angle you need to find. We want to find angle A. So since we're finding angles, the law of cosines for angles would be cosine of A equals B squared plus C squared minus A squared, all over 2 times B times C. That is for cosine of A. Now, if I was finding sides, it would look like this. A squared, this would be for sides. But this is not what we're doing. We have side, side, side here. But if I was looking for a side, it would look like this. A squared equals B squared plus C squared. Let's see. Minus 2BC cosine. And I can't write 2BC cosine A. Now, if you solve this for A, solve this equation for A, it would look like this, all right? And that's how you get this formula. This is when you're looking for angles. So instead of just doing this, I remember, okay, for angles, I'm just going to solve for cosine of A, basically. I'm going to subtract these two, and then I'm going to divide by 2BC. Negative 2BC. That's why these all flip signs. All right, let's go ahead and just do what we've got here. We've got B squared, C squared, A squared. All right, so A, let's just write it down. A is opposite angle A, that's 37. Turn that off. B is opposite angle B, that's 47. And then C is opposite C, and that's 55. So this will look like this. Let's go cosine of A equals B squared, 47 squared, plus C squared, 55 squared, minus A squared, 37 squared, all over 2 times B, which is 47, times C, which is 55. And then this just becomes a big fat calculator problem. Plug this all in on your calculator, 47 squared plus 55 squared, subtract off 37 squared, and then divide it by 2 times 47 times 55. Do this first, do this, then do the division, okay? Order of operations. So you do all that, you're going to end up with cosine of A. If you do this all right, you're going to get about 0.7475. Now, when you're looking for an angle, you have to do the inverse cosine. So on your calculator, to get the cosine away, to get the angle away from the cosine, you have to inverse cosine both sides, basically. So the cosine inverse of 0.7475, and that is the arc cosine. It's not 1 over the cosine, that's not what that means. It's the inverse cosine, okay? That's confusing. The arc cosine. So some students will say, like, cosine to the -1, doesn't that mean 1 over the cosine, which is the secant? No. Okay, the cosine with that little -1 there on the inside, that means inverse cosine. Okay, that does not mean, this does not mean 1 over cosine x. Okay, no. This could possibly work. Cosine of x, if you took that and then put a -1 here, that could mean this, okay? But careful. Careful with that notation. I hate that they use that notation because that's so confusing. I like the arc cosine. Some calculators have that. All right, so calculator. Use the cosine inverse button on your calculator. You get 0.7475. Go ahead, 0.7475, and you're going to get approximately 41.6 degrees. And there you have it. All right, guys, good luck on this. Careful with your graphs, and go ahead and email me if you have any questions. You can use your notes on this test. I will allow you to use your trig circle if you'd like. Good luck.